Good morning, Los Angeles. It's January 28, 2022. Okay, this is David De Los Reyes. I am now on lesson number 19 on my integral calculus on my channel. Okay, let's start the discussion for today. My topic for today is powers of cosecant and cotangent, meaning the integration of problems that involves the combination of a cosecant and cotangent. Okay, I will give you example number 1 for today. This is not a viral video. This is an educational video, so it's up to you guys to subscribe to my channel. Okay, let's proceed. Example number 1 for today, this will be the integral cotangent to the fourth, cosecant to the fourth of x dx. It's a combination of a cosecant and cotangent. Okay, let's bring out the solution. This should be equal to cotangent to the fourth, okay, cosecant square of x dx. This is 2 plus 2 and this is equal to 4. We just expand the cosecant in terms of the two terms, okay? Cosecant square and cosecant square. Continuing, this should be the integral cotangent to the fourth of x. We will replace cosecant square by 1 plus cotangent square of x times cosecant square of x dx. Okay? We replace one cosecant by its equivalent in terms of cotangent. Okay? Then we try to expand. Cotangent to the fourth times cosecant square of x dx, it is this one. Okay? The next term will be cotangent to the fourth, cotangent square. We got a cotangent raised to the 6th power because 2 plus 4 is 6 times cosecant square of x dx. Okay? If we try to observe it, the resulting expansion are now both integrable, right? Where the value of u is cotangent of x and the value of du is negative cosecant square of x dx. If you try to take the differential of cotangent, it should be negative cosecant square. So du is actually negative cosecant square of x dx. It is not exact. Why not exact? We are missing the negative sign. Okay? So for these two resulting terms to be integrable, we will insert the negative sign outside the integral sign. So they should now be equal to, continuing with the integration. We integrate this one, we insert negative 1 outside, the integral cotangent of x to the fourth times the complete differential as per verification negative cosecant, sorry for this one, this should be square, okay, negative cosecant square of x dx plus open quantity. We insert also negative for the second term, okay, negative 1, the integral cotangent of x to the 6th power, we are following this, times the complete differential. Sorry again, this should be cosecant square of x dx. Right? We place negative, we put the complete differential, and both terms now falls under the power formula. Okay? So cotangent raised to 4 plus 1, which is 5, all over 5, okay, minus, plus and a minus, it will be a minus. this should be cotangent raised to 6 plus 1, which is 7. Okay. Sorry for this one. This should be 7. Right? It's correct. Because 6 plus 1 is 7. So the denominator will be 7. So final answer, this should be minus 1 over 5 cotangent to the 5 of x, minus 1 over 7 cotangent to the 7 of x, plus c. That's the final answer. Okay. Let's proceed with the next discussion. We are now through with powers of cosecant and cotangent. So I will now give you a problem that involves power of cotangent only. Cotangent. Okay. The given problem is this. The integral of cotangent to the fifth of theta differential theta. It's a pure cotangent. Okay. Let's proceed with the solution. This should be equal to the integral cotangent cube of theta, cotangent square of theta, differential theta. We just expand. 3 plus 2 is actually 5, right? Then we will replace this cotangent square by its equivalent in terms of cosecant. Cosecant square equal to the integral, I just write cotangent cube of theta. Cotangent square of theta is cosecant square of theta minus 1. Okay, times differential theta. Expanding. Cotangent of theta raised to the third power. Okay, times cosecant square of theta differential theta. That's the product of this times this. Minus 1 times cotangent cube is negative the integral of cotangent cube of theta differential theta. Okay. I will rewrite the first one minus the integral. I will replace 1 cotangent square here by cosecant square of theta minus 1. Okay, that's cotangent square of theta times cotangent of theta differential theta. Rewriting again the first one minus the integral. This should be cotangent times cosecant square of theta is cotangent of theta raised to the first power cosecant square of theta differential theta. Negative 1 times negative 1 here, this will now be plus. Okay? The integral of cotangent of theta. Sorry for this one, this is with the differential theta. Right? For the second term, the value of u, it falls under the power formula. Okay, even the first one. Where the value of u is cotangent of theta, du will be negative cosecant square of theta, differential theta. It is not exact. So we are actually missing the negative sign. So to integrate the first two terms, we will introduce a negative sign outside. Okay, it's a little bit automatic. D falls under the power formula. Negative 1, open bracket, cotangent raised to 3 plus 1, okay, which is 4, all over 4, minus the integral, open quantity, negative 1. The second one also falls under the power formula. Cotangent raised to 1 plus 1, which is 2, all over 2, plus the integral of cotangent of theta. This was cotangent of theta. I expedite a little bit. I put that cotangent in terms of cosine and sine. It is actually cosine theta over sine theta. Cotangent is cosine over sine. We integrate this one already. Okay. We are just awaiting the integral of this. But the integral of this, it falls under the natural logarithm. The value of u is the 1 under root sine of theta. du is cosine of theta differential theta. It is exact. Okay? So the integral of this falls under the integral of d over u. And it is actually the integral is natural logarithm of the function, okay? So simplifying, negative 1 all over 4, this is negative 1 for cotangent port of theta. I am simplifying the first two answers, okay? Minus, minus, this will be plus. We got it 2 underneath, so this is 1 over 2, 1 half, cotangent square of theta. And the integral of cosine theta differential theta over sine of theta is just the natural logarithm of u, which is sine of theta plus c. That's the final answer. Okay? We integrate the first two while we are awaiting the integral of the last one. I present the solution. The solution is natural logarithms of sine of theta. So the final answer, we will just copy this one and this one, okay, plus the integral of the last one. So the final answer will be minus 1 fourth cotangent to the fourth of theta plus 1 half cotangent square of theta plus natural logarithms of sine of theta plus c. That's the final answer. Okay. We are now through with cotangent. Cosecant and cotangent, we are done. Pure cotangent, we are done. Okay, let's bring out the last topic for this afternoon. It is power of cosecant only. Meaning, the given problem only involves power of a cosecant only. Okay, let's bring out example number 1. Example number 1, for cosecant only, the integral of cosecant to the fourth of theta differential theta. It's an even number. Okay? Cosecant to the fourth is cosecant square differential theta. 2 plus 2 is actually 4. Okay? Then we will replace cosecant square of theta, the first one, by its equivalent in terms of cotangent square. And that's actually 1 plus cotangent square of theta, okay, times cosecant square of theta, differential theta. Expanding. 1 times cosecant square of theta, differential theta is this. Cotangent square, cosecant square, differential theta is this. The first one is now integrable. Right? The second one, let's verify. It falls under the power formula, where the value of u is cotangent of theta, du will be negative cosecant square of theta, differential theta. It is not exact. Why not exact? There should be a negative sign in the complete differential. So we will introduce negative 1 outside, and we can proceed with the integration. The integral of cosecant square of theta, differential theta, that's a perfect formula, negative cotangent of theta. Right? Plus, open quantity, negative 1. We introduce the negative 1 here. The integral, cotangent of theta square, times the complete differential as per verification, negative cosecant square of theta, differential theta. After placing this negative sign inside and negative sign before the radical, it now falls under the power formula. So the final answer, we rewrite this one, negative cotangent of theta, okay, plus and minus, that will be minus. Cotangent raised to 2 plus 1, which is 3, okay, so that will be cotangent cube all over 3. That's over 3, plus c. Final answer, simplified final answer, negative cotangent of theta, negative 1/3 cotangent cube of theta from the integration of this, plus c. That's the final answer. Easy if you know your identities. Okay, let's bring out the last example for this afternoon. It's the complicated example. The last example for today, which is complicated, is the integral of cosecant cube of theta, differential theta. Similar to the integral of secant cube of theta, differential theta. And that problem we could not solve without introducing the so-called integration by parts. So to attack the solution of this one, we will bring out the formula for taking the integration by parts. And that is actually, okay, I will read it. The integral of cosecant cube theta differential theta can be written as the integral cosecant theta to the first power, cosecant square of theta to the second power differential theta. 1 plus 2 is 3. We just expand this, okay? We rewrite the given problem as cosecant and cosecant square of theta. And this is actually to be solved by using the integral of udv, which is equal to ub minus the integral of b du. And that is actually integration by parts. So the solution of this is actually integration by parts plus our knowledge of identities. Without introducing this one, and you use only your trigonometric identities, you cannot solve this problem. Okay? Okay, let's continue with the solution. After rewriting the given problem as cosecant theta, cosecant square theta, differential theta, I let u to be cosecant of theta, the first one. And dv will be cosecant square of theta, differential theta. Okay? So if my u is cosecant of theta, what is my du? Du is the differential of this. The differential or derivative of cosecant is cosecant cotangent negative. Okay? So negative cosecant theta, cotangent of theta, differential theta. That's my resulting du. Okay? My dv will be cosecant square of theta, differential theta. It is this. Right? If I will try to compute for b, I will integrate both sides. Right? The integral of the differential of b is just b equal to the integral of cosecant square of theta, differential theta. The right hand side, we are just lucky. This is integrable. Okay? Because the integral of cosecant square of theta, differential of theta is just negative cotangent of theta. It was a perfect formula from the given formulas, okay? So proceeding with the integral of cosecant cube of theta, differential theta equal to, we will follow this. It is the product of ub minus the integral of b du. Right? U is cosecant of theta. Okay? What is b? B is negative cotangent of theta. So I now place the negative sign over here. Okay? So this was plus originally, but b will be negative, so I place the negative sign here already. Negative cosecant theta, cotangent of theta, that is the product of UD. Minus the integral. What is b? Negative cotangent of theta. And what is du? Negative cosecant of theta, cotangent of theta, differential theta. Okay? We will just rewrite the product of this. Minus. There will be two cotangents here. So there is a cotangent square. But this is minus, it will be plus. But this is preceded by minus, so it will still be minus. Okay? We replace cotangent square of theta by cosecant square of theta minus 1. Because cotangent is cotangent square. Times cosecant of theta, differential theta. Expanding this. We rewrite this. Okay? Cosecant square, cosecant theta will be cosecant cube of theta, differential theta. This is negative side. Right? This is minus, so this will be plus cosecant of theta, differential theta. That's the second term. Then to expedite a little bit, we are minimizing our space on the blackboard. I will now try to multiply cosecant of theta by cosecant of theta plus cotangent of theta all over cosecant theta plus cotangent of theta times the differential theta. For the cosecant of theta to be integrable, we can introduce this one because this is actually 1. Right? This one. After introducing this one, it's now integrable. It will be, the denominator will be cosecant square of theta, the product of cosecant theta, cotangent of theta. It seems, after multiplying this by this factor here, it falls under the natural logarithm. Let's verify the value of u. The value of u is the one underneath, cosecant theta plus cotangent of theta. du will be equal to, the differential of cosecant is negative cosecant theta, cotangent of theta. And the differential of derivative of cotangent is negative cosecant square of theta, differential theta. They are both negative, so I factor out negative, I bring out negative here. And the one inside is cosecant of theta du will be equal to, I'll just copy this, cosecant theta, cotangent of theta. There's a little problem here. So this will be negative cosecant square of theta plus cotangent of theta, cosecant of theta plus quantity differential theta. It is exact as the product of this, except for the negative sign. So the integral of this, we will introduce negative 1 outside. Okay? Okay. But this is cosecant cube of theta, differential theta, right? We place that on the left, so it will now be 2. Cosecant cube of theta, differential theta. We rewrite the first one. The integral of this is plus open quantity negative 1, the natural logarithm of cosecant of theta plus cotangent of theta plus c. But the problem is only asking for cosecant cube of theta, differential theta. So we will multiply all of this by 1/2. So these two here cancel with this. Therefore, the integral of cosecant cube of theta, differential theta equal to, this is negative, negative, I bring it out, okay? We divide, we multiply also the right hand side by 1/2, so there's an over 2 underneath. So the common factor will be negative 1/2, okay? Cosecant of theta, cotangent of theta, plus the natural logarithm of cosecant of theta plus cotangent of theta plus c. That's the final answer. We just remove the 2.